This will be a purely algebra guide on how to solve for the kinetic coefficient of friction given some distance over time. So let's assume that we have sort of like a rather flat surface with a box. We'll call this M1. Right, it's connected to some pulley, right, over some table, and we'll call this M2. Okay? And after after some time, right, after some time, we'll call this S, it falls some distance, right, we'll call this change in X. So how will we find what is the kinetic coefficient, right? So this is mu k, k. Seems kind of difficult, I suppose, right? I mean, you're only given so much information. But let's just review some facts about this system in itself. Because these two objects are connected, we can assume that the acceleration for m1 and m2 are going to be the same. Furthermore, right, tension, right, this is T1, T2, they're going to be the same because they're both connected to the same line, right? Why they're the same? Newton's third law. Given this facts, right, how can we calculate? Right? After some time s forgot, right? Starting at rest, right? Starting at rest. So that means v naught is 0. So how would you calculate acceleration? If this falls after 1 second, falls some distance. Why? My bad. So so the change in y is equal to, right? If you remember your kinematics equation, t squared, right? V naught plus v naught times time plus 1/2 at squared. Since v naught is 0, the final equation is only 1/2 at squared. So you're given this, you're given some time in seconds, right, which is basically t, and you're finding acceleration. So you can calculate acceleration. So you're going to get change in 2, this goes over here, divided by t squared equals acceleration. Alright, now that you calculate acceleration, you can calculate the tension. Right? Realize that going back to our free body diagram, we know that there's a weight, right? There's a force of weight mg. Right? So the mass times gravity equals to weight. And we also know that there's also an opposite force called tension, another way. So we write the equation, we can write mg minus t, right? Equals, because you know Newton's second law, right? This is the total force right here, and this is equals to mass times acceleration. Mass of m2, right? So you can calculate tension through t equals m2 to negative m2a minus m2g. Right? You only want tension, you want to get rid of the negative, so you're just going to get t equals to m2g minus m2a. 2 is just a subscript. So you calculate the tension, T2, right? Well, we know T2 equals to T1, so this and this, because we calculate the tension for T2, we also calculate the tension for T1, right? They're basically the same. So now let's look at the forces on the x direction, right? Because, You know that this is the force of friction. Now looking at the forces, the overall force, we know it's going to be T, right? It's going in the positive direction. That's why this is positive T minus the total force of friction equals to M1, right? M1 A. Once again, we use Newton's second law. So from this, we know negative F equals to M1 A minus T. So F is just equal to T minus M1A. Does that make sense? Right. So we calculated T and we calculated what A is, right? So what we have to do is just substitute in, right? We know the value for A and we know the value for T. So total force of friction is just equal to T, which is M2G minus M2A minus M1 times acceleration, which is 2 change in y, change in distance on the y direction, T squared equals to the force of friction. We also know that the force of friction is equal to the kinetic coefficient of friction times the normal force. So what is the normal force? Well, in this case, the normal force is just the perpendicular force going upwards, and we know that the weight is just mg. Because it's at rest, the normal force, right, minus mg is equal to 0, so n equals mg, right? They cancel each other out. These two forces cancel each other out, which is exactly why you don't see, well, this block falling straight through the floor. So what you can do is substitute F with this value, right? So we know F equals to U, A, M, right? K is just a subscript. So I'm just going to move this over here. We have UK equals, well, UK MG M1, right? Oh, this is M1. Sorry about that. M1, right? M1G, because you're looking at, if you're looking for the coefficient of friction with this, with respect to this mass, right? There's no ground here for it to have friction. Equals to M2G minus M2A minus M1 to change in y over t squared. Just divide the entire thing by M1G. So you're just going to get UK. And UK is just equal to this value right over here. That is how you solve for